Assalamu alaikum students and welcome to the second part for structures and the chapter number 10 for C language, in which we are discussing now here today a little bit portion from the structures. We will also talk about the uh, typedef command, which is actually just alias over there. And then we are also going to talk about the union command as well. And then I will just have this will be a very small part because I don't want to discuss the bit manipulation thing that I will be actually discussing in the next part over there. So this chapter I have bifurcated into three parts over there. So, and this is important for your lab. So that's why this is part 2 over there. Now, before I move on towards a little bit more about structures, in my last part, I saw that there was some uh, discrepancy, or you can call it that it has not discussed the structures and the pointers over there. So before going on further, we remember it from the first part that the pointer is going to be making a memory location over there. But before that pointer, if you remember it, this dot operator was actually the thing that was actually going to access the members of that structure. Now, when you are going to access your member of your structures, as you can see this one over there, in this case, you can see over there assigning the values to the members of SN. So SN dot marks is equal to 13 SN. And this is the easy way of accessing a structure. The structure has been given a declaration here, and then afterwards it is initialized, or not initialized actually, this is actually, you can call it as a super grid type or data type over there. And then afterwards you are making a structure called as SN over there of the record data type over there. And record has its members such as marks, quiz 1 marks, quiz 2 marks, and quiz 3 marks, and grades over there. Now, if you are going to make a structure over there, let me just do that. If you are going to make a structure record, and here you are going to make a pointer. And since I'm not going to make it, and so let's say let's call it as a student over there. Now, when I have made this as over here, the student is actually a pointer to a record, which is the structure, and I have still not given it as an address. So now when I want to give it an address, let's say I want to give it an address, so I can now call it, let's say this will be equal to and here let's supposedly I call it SN. So when I have written this like this over there, now what this is actually telling me that the pointer student, which was actually pointing out to any record, has now been given the address of the structure SN. So now when I have called this student as having the address from the memory location of the SN structure over there, so this means that now, let's say if I don't have this, I'm not putting any value over there inside the SN over there. Let me just put it over here, and I'm just commenting out this one over there, and like this one. Oh, sorry. So when I have this one here afterwards, let's say I have this one over there, and now I can, if I want to know, now I can't access the SN by using the dot operator. Because student is a pointer. So here I will have to use this thing, student. And now when I have put this pointer or arrowhead, actually, I call it as the arrowhead over there. You can search the name on the Google, whatever it's called, but normally it is a dash with the greater than the symbol, but I normally call it as the arrow. So as soon as I put it, my Visual Studio Code is telling me that student, which is a pointer to a structure, and at the back end is actually pointing out to the SN, has all these members, and it is giving me and showing me. So if I want to now change the marks, I can now put it, supposedly, let's say he has got 20 by 20. And here, let's say again student, and I want to again change it. Let's say I want to change the quiz 1 marks, and that is also going to be like this, like 10 over there. So in this way, whenever you have a pointer, and now why pointers are used actually, because whenever you are going to change your record, you need that name. Okay, and if you have a record over there and you have a pointer over there, every time you can change the address of that pointer, and you can point out to some other record. So if supposedly this was student equal to SN, I have changed their settings over there, and then afterwards, let's say I want to now change the to, let's say, to, instead of student, I want to now change it to for and Zainab. So now what is going to happen? Now when I'm going to change this data, this is going to change the data of Zainab. So pointers here are just like, you can call it as an arrowhead. And first of all, it was pointing out towards the SN structure. Now it is pointing out to the Zainab structure. So this is the correct way, and that's why you have to use this arrowhead over there as shown in this slides as well. And I told you that this card PTR was over here, and this card PTR is going to be giving on to this one, and you have to avoid the spaces. Remember, the spaces has to be avoided over there, so it has to be something like this. You can do this very same for the dex 0 as well over there for an array as well, but array, if you're going to give it as a pointer, then it will be having a different perspective over there. You don't need to then tell the and symbol over there and all that stuff over there. The same nomenclature from chapter number 6 of arrays and chapter number 7 of pointers will come into play. The only thing that is different over there in this chapter is that you're talking about a structure, and structure has its members. And when you have a structure over here in form of it, that structure is having a nomenclature over here. And when you give the command struct record sn, you make actually a structure with the name sn, and sn has members, which is the marks, quiz 2 marks, quiz 3 marks, and grades over there. So I hope you're getting this point. And the same thing is defined over here in the slides over there. Sorry, the links over there. I've given this link in the part 1 as well. I will share with them in your second part as well. So this is the pointer to the structure. Same thing over there. If you want to have a pointer to a structure, then this is going to be, this is different from the self-referential. Please remember, this is different from the self-referential. We'll come back to it later on when I just show you the nested structure just now. So this is a declaration to the pointer to a structure. Same thing, struct books, and the name of that pointer is struct underscore pointer. Then in the next line, I have struct underscore pointer is equal to and book one. What is book one? Book one is a structure. In my case, it was Asan or Zainab. And then afterwards, I can change that thing. So if I had a strict structure book over there, and book was having this book one was the name of that structure over there, and it has the data over there. Now afterwards, I make a pointer, and that pointer is, I can change that thing by using this arrowhead operator, that is the dash and the greater than symbol, and I can change any of the members of that structure over there. So in this way, if you want to modify inside a for loop or a while loop or any other function as well, you can do that very easily. An example over there, just like mine, is over here. You can see over there, in this case, you have a structure over there. You have the string also included over there, and the stdio.h as well. And here you are actually changing that structure over there. This is a structure built up, that is book one. And then afterwards, I'm giving a pointer to a structure, the address of that structure which I want to change. Then afterwards, I can print it by using this operator. Don't worry with this space over there. I guess the space is over here not being included. So when we are going to run this, you can see the print is over there using this command over there. So practically, I guess when I'm going to see this thing, the space is not going to be a problem. So this is exactly the same thing which I've shown over there, that you are changing the structure over there. And if I can compile it over there, let me just compile it. I guess I have selected again. Okay, no, I have done it. So you can see now, because I have put a 20 for SN and 10. So you can see SN number is equal to 20 and quiz 1 marks are 10. So here the pointer is actually changing it by, because the SN which I was changing or accessing the members of SN by the dot operator is now changed over there. I'm accessing it through the pointer or structure pointer over there. So this is exactly same thing, and this is being shown over here in this example as well. I showed you this example previously also. So this was accessing the members over there. It has two pointers inside the structure over there. So here you are accessing it over there by using again the arrow operator over there. So this is card PTR. Card PTR is a pointer. So that's why you have this static over there, and you are giving it my card. What is my card? My card is a structure which I want to change. So when card PTR is there, card PTR arrow operator face. So what happens? The face value, which is stored, of course, in the memory, because it's a pointer and it's storing some string over there in this case. So this will be ace printed over there. And if I want to have this suit access, so this will be ace and spade printed over there in this case over there. Or if you want to not use the arrow operator, then you can use this static card ptr dot face. And why? Because first of all, you have to dereference the card ptr, because that's a pointer, by using the parenthesis over there, and then dot operator can be used over there for these two cases. And this is the percentages for the format specifier of the string over there. I hope this example is now clear. Last part I was a little in haste over there, and I have not discussed it in detail. So this is the way how you are going to access by using the pointers, or if you are having a pointer inside. And remember, this is not self-referential, just like the previous case in part 1. I discussed about that, how you are going to have a reference self-referential to another structure of maybe different employee. Okay, I will come back to this when I'm going to discuss the nested structure. This is not here in your chapter, but I'm going to discuss it from the website just now. But before that, let's see some examples over there. So let's fill in the blanks over there. So I have a fill in the blanks over there. Let's see this one. The structure dash dash operator and the structure dash operator can be used to access structure number. Okay, now this is a little difficult for me even as well. The structure dash operator and the structure can be used to access I guess the pointer operator, I guess is the answer. Oh, sorry, the operator. I'm talking about the dot operator and the structure, and this is the arrowhead. Sorry, this is the arrowhead. This is a mistake in the slides over there. Don't worry on this one. This is again the dash and this one. So the statement is that the structure dot operator and the structure dash greater than symbol or the arrow operator can be used to access structure map, which is already true over there. It's a little difficult to understand this thing because the operator word is being used over there. But anyway, this is the dot operator and the arrowhead operator that can be used to access structure members. We already know it. We have done it. Then another example, question over there, the expression card, PTR, arrowhead suit is equivalent to, yes, of course, the parentheses are optional. No, parentheses are not optional. They are must to force the dereferencing of the card PTR pointer first, and then afterwards it is going to access the member of the suits over there. So parentheses are not optional. So you can see the answer is that it's false. The expressions are equivalent, but parentheses are not optional because dot has higher precedence than the steric operator. If you still want to see the preferential operator table or the prevalence of the table operators over there, that is available in chapter number 7 and chapter number, I guess, 8 as well. Kindly go through that one just to remember it again. Then next thing, which is very, very important, which is calling passing structures to function. But before that, I can pass a structure to a function. Let's just first of all go to the nested structure thing, which is very, very important. And that is part of this w3schools.com. And I want to actually discuss it because in your last week of your lab, we are going to have a nested structure also available, and the task will be a little long. It will be just one task or two tasks. So it will be including structures and some file data which has to be written over there. So you have to use nested structure for that case. Now, if you see over there in this example, now you see this example very carefully and understand this thing and why nested structures are required. The first structure over here, which is being just defined over there, not initialized over there. This is just a nomenclature, you can call it, which is called as struct owner. And inside it has two members, first name, last name. So there is one structure which has the owner of a car, of course, over there. And then I have a car which has car character brand over there, of course, array for the character array. And then there is int year, and then there is struct owner. Now this is inside a nested structure. This is called as the self-referential over there, but this is not actually using the pointer over there. What it is using, this car has inside a member, which is the structure itself. So just go to Nadra, you go there, inside your structure, you have your name, you have your age, you have your blood group and all that. And inside it, you have another member of your structure, which is your father's name, because father name is also a member of another structure. So that is also a member. So inside your structure, you have a member, which is also a structure. But here it's a structure is of different kind. So that's why that structure is called as owner. And inside you can see the word is struct owner. So now this is a nested structure. So one structure of car is there, and inside it you have a member, which is also a structure. So here, what you are doing over there, now see this very carefully. Inside the main function, you have struct owner person. So owner is that person over there, and that is John Doe. That's the name of that person who has the owner. Now it has not been linked to the car yet, but afterwards, inside this one, when you are defining the car structure for one car, that can be car one or car two or car three. Supposedly a person has two cars or three cars. So this car one would be equal to Toyota 2010, because the brand over here is that thing. So this is Toyota. Remember, this can only be initialized inside this parenthesis. You can't do it by the dot operator. Otherwise, you have to use this string copy command. Don't do this mistake whenever you are doing an example or something in the lab. Then year 2010, of course, year can be there in the 2010 category. And then The third thing is a structure. So you have to give the name of the structure which you are having that thing. Now remember one thing, you can't define this thing before this thing. So you have to first of all define the structure which is being used inside another structure. So person has to be defined before you are going to use it inside this car one. Now, if this was the car over there, this was the owner. So car is referring to the owner inside it. And supposedly car was being taken up by some inventory inside the government scale for excise and taxation. So there in that case, it will be another structure which will be taking in the structure of car. And car itself has the owner, which is another structure. So you can see nested structure by 1 and 2 and 3. This tree can go on. Then afterwards, if you want to now access the first name, last name of it, very simply printf car1 dot brand, because car1 is the same structure name, which is the car nomenclature. So car1 dot brand, this is going to be printed, which is actually Toyota, which is going to be printed. Then car1 dot year is going to print 2010. But in the next line, when you are going to print the owner over there, so this is going to be car1 dot owner dot first name. Now you are going in car1 dot owner. What is owner? Owner is the third member of that structure, which is already a structure inside. So that is owner dot first name. So this is owner dot first name. This will go in the next structure, the first structure over there, and you are going to print it. So if I just run this thing, let's just see, and it will take some time because it's going to take it from the compiler. So you can see now the owner is John Doe. So if supposedly, let's say, let me accept this preferences. So if I have a owner person, let's say I want to change it name, and I want to change the name to, let's say, my name over there. And here, since I have a Honda over here, and I have a 2017 model with me. So when I'm just going to run it, you can see now. So when I'm going to run it, it will take some time because it's going to take the server. So you can see a Honda 2017 Aslan Reem. Now, here, if I want to now have, let's say I want to have another car, Struct, sorry, not Struct car, since I have two cars, let's say, and I want to now own a Kia car as well. That is 2022, I guess. And I am the same person. Of course, I am the same person. So now what is going to happen? Now let's see what is going to happen. I have car one, car two. So now if I want to print it, I can have the same line printed, and this time it will be car two dot here. So now two cars are going to be printed over there. I have done some mistake or not. I guess I have missed, oh, sorry, I have missed the parenthesis. Sorry on this one. Please don't do this mistake. The parentheses are very important, the curly brackets actually. So you can see now the owner is Aslan car and all that stuff is being written over there. So in this way, now this is owner and car. Try to have a 3-level nested structure as well, which is also possible. The car is going to be inside a record of the excise and taxation department, which will be knowing, okay, this is the car registered over there. The owner is another structure over there. And then inside excise and taxation, that may be referred to FBR, Federal Board of Revenue, the taxation authority. So they will be accessing. So in this way, one structure is accessing another structure, which is a member of its own structure over there. So this is a classic example of a nested structure. And you will be required to do this nested structure inside your last lab, which is actually going to be very important lab. And it will be a just one task for like maybe like 2 hours, 3 hours over there. So this is the nested structure which you have to use over there using the dot operator again. Now remember, you can see over there because you have 3 level of nested structure over there. So you have the first level, the second level, and the third level over there. In fact, it's 2 level actually. Car one is actually the name of that structure. So this is that first level, this is the second level of that structure. Now, if you have like 3 or 4 different levels, you can do it. And this exceptions over there, sorry, on this part. So this thing which you are seeing over there is actually being referred. I am again sorry on this part. Where is my? So this is being first nested structure, the second nested structure being referred over there. Then afterwards, this is the nested structure. I guess this is only important for you. You can easily now have the structures being accessed. Now let's go to how your nested structures can be accessed by functions. Now, whenever you are going to pass a structure inside the function, there are 3 ways. First thing is you only pass a member by using the dot operator. That is the first thing. Individual members by value. That is by value. Only value is ref path. You can't change the whole structure member value permanently over there. You can't do that. Then second thing is entire structure. Again, that is also passed by value. You can't change the structure value permanently. The third thing is by pass by reference, which means you are going to have a pointer to a structure. Again, now here comes the pointer. That is a static symbol, and that will be by reference. Here now you can change it. You are not just accessing it, you can change it over there, and that will be permanently done inside your structure over there. Next thing, see the three examples. Void function int age. This is a member by value. You can have int age over there, which means int age is a member of a structure, and that value will be copied over there. I will just show you the example. I just will now. Second thing is struct employee. So you have to just write down the word struct. Employee is the nomenclature of that structure which you have defined above your main function, and emp is the name which you are going to use inside that function. These are the three prototypes of the function which I am accessing over there. Third thing, or the third way of accessing or passing the value or pass by reference is by using the static operator. Now, static operator is actually a pointer to that structure. So now you can do it. Now, passing by reference is more efficient for large structures. Now, I am just showing you over here a structure which has like just 4 or 5 members. Just imagine it out. Supposingly, there just a little hint for you. In the last lab, if you are going to make a supposingly a bank structure. Whenever you open a bank account does not just take your name, your father's name, your date of birth, your amount of the money in over there. It also takes in how many transactions you are doing, who is referring to you, what is your CNIC number, what bank you had previously before. And if you remember it, whenever you go to in a bank in Pakistan or anywhere supposedly in the world, they send your data to some other bank or the State Bank of Pakistan here, and they do a back check that you are not involved, you are not a terrorist or something, and you are not doing any something, a black money to white money or something like that. So you are an NTN number or something like that. You are a taxpayer or something. So a back check is there. So the structures are very, very complex. So whenever you are going to, and you want to change that structure, then you have to use the pointer. Now remember, a cashier is sitting on the bank. He's just a cashier. You just have to take your checks or maybe pass on your bills and then just submit the amount. Those cashiers, they are not allowed for any static operator or this pointer to be, because they can't change your account. They take your check, they give you the amount, that check is sent on to some other higher grade officer who then deducts your amount from that over there. He's not allowed, but otherwise he can actually deduct or increase your amount over there. And plus they keep a record of it, because maybe some of the whole of the 10-15 members of that bank, they are colluded with each other and they decide on it. Okay, now we are going to increase the amount by like 1 crore or 2 crores for one other person. So the bank sitting, or the bank manager or bank at the back end in Karachi, the head office is not going to know. So they keep a copy of it. That's why banking structures are now more digital. So they have to keep a copy. Previously, like 20-25 years back or 30 years back, it was very, very difficult to actually then have a check. It was going to take a lot amount of time. They have to do it manually. Now they have to put it digitally inside. So structures inside a bank, Nadra, or some other structure, they are very, very complex, and they are nested structures and interlinked structures a lot. Maybe there is a whole train of structures over there, and then it is also linking with another structure, which is also a train. Plus self-referential are also there. I will give you an example of self-referential maybe in the end part of this lecture, or maybe in the next part over there with an example. Next thing, example, pass by reference or pass by value. Now here I have three, or sorry, in fact two. The first one is actually not important. Why not important? Because it's just a simple value. So whenever you are going to make a function, let me just show you that example over there. Let's say above this main function, let's say I call it void and print underscore value, and inside I call it let's say car grade. That's all. And this is the prototype of the function. Now, when I have going to write down this function, let me just over here. Again, I want to write down void print underscore grade, and inside it I have car grade over here. And over here, what I'm taking over there, I'm just going to take printf the grade you wanted to print is, let's say, and here you are going to write down %C over here, format specifier, and here you are going to just write down grade, and that will be all. That's all. So supposingly you want to print your grade over there. So let's say after this thing, your grade has not been defined. Let me just put SN has a grade. Let's say I'm putting a SN has a grade over there. Let's say it has a grade over there, and I'm putting a grade of A. So he has got an A grade in this course, let's say. And after this one, I want to print it. So this will be print underscore grade, and inside it, what I'm passing now, let's see this very carefully. I'm going to pass SN, or I can pass student. Let's say I have student over here and grades. That's all. So what will happen? I'm passing just the value over there. So what it will do, it will print the grade you wanted to print is this. Let me just run it. Sorry, I have actually selected or something. I hope so. I'm using the, actually I'm using the grade operator. Print under, I have not done something wrong. Oh, sorry, print underscore value is the function. Sorry. My bad. I have to print underscore value. And here, this is also print underscore value. I have named it wrong, actually. Sorry. So when I have done this, we get the grade you wanted to print is SN number equal to 20. So you can see now when I'm printing it, student grade SN number is being printed over there. So A is being printed over there. And afterwards, you can call it puts like this. And sorry, I have to, yeah. So now you can see the grade you wanted to print is A. So you are just sending the value inside a function. You're not sending the whole structure. So this type is not important over there. That's why in this example, you can see you are actually having void print employee struct employee. So here you are sending the whole structure, but only its copy. So it makes a copy. It's slow for large structures. So this is run. And here you are doing a printf. And here you are printing it employee.firstname, employee.last name. So here you are sending the whole structure inside as a function parameter. And inside the function, you are now printing the members of it, or if you want to do some mathematics of it, whatever you want to do inside it. So here you're just printing it. But if you now send struct employee static emptr, now you are sending by reference. You're sending the whole structure as a reference over there. So now when you are going to do it, you are going to use the arrow operator. Remember, the arrow operator is a must now because you have a pointer over there, or otherwise you have to use the parenthesis with the static dereferencing operator. So these are the two classic cases of passing by value or passing by reference. This one is a passing by value. This one is a passing by reference. And here you have a structure employee EMP1. This is John Doe 3025.50. Okay. So of course you are going to print the employee. This is the first thing. This is a print employee. You are sending here EMP1, and then you are having EMP1. Now remember this thing over here, two functions having the same name. You can see the name of this function, same, name of this function, same. The only difference here, this is having a structure by value copy sent over there. Here, this is a pointer to a structure being sent. So here the whole structure is being sent, and here inside it, you can change that structure as well over there. Then next thing, very important, passing arrays by value using structure. You can do that even as well. For example, let's say you have a structure and inside it, you have an array of 100 numbers from 0 to 99. So here you are going to processing an array. So here you send struct array wrapper ARR. You are just sending the structure copy. Here you are sending. So changes to ARR dot numbers don't affect the original. So if you are going to do something like this will not happen. But if you are going to send a static, which means a pointer, then you can do that. So here inside int main void, you have structure array wrapper my array. So you are now sending a 1, 2, 3, 4, 5. Remember, these are two parentheses over there or two curly brackets over there, because this one is for the first member, which is an array. So if there was like second member over there of this structure over there, then that will be separate after comma for this structure. So it will be 1, 2, 3, 4, 5. The only 5 values are copied over there. So process array my array is copied. So here my array dot number 0 is still 1. Okay, so it's not going to change by this structure over there. So this value is not going to change because this is a copy of this one. If you want to change it, then you have to use the dot, or sorry, the static operator, which is the pointer over there. So then the function definition would be structure array wrapper static ARR. That will be actually the pointer to that structure over there, and you have to send this one the pointer over there. Next thing, let's go on the self function. Structure objects and individual structure members are passed to function by value. You don't need to over there. So this is going to be by value as shown over there. So this is by value over there. Then next thing, how can you pass an array by value? I guess this is very simple. I have already given you an answer. Simply place the array in a structure and pass the structure. Structure is normally passed by value. Same thing I just told you over there. So nothing fancy over there. So you can just do it over there. Next thing, which is now very important, which is called as type def. Now, what is this type def? Type define or type def simply creates synonyms or aliases for existing type names. Now, this is a little, what is aliases? Now, if you go on Google and find out the word meaning of aliases, this means just same name, just like you give a short name to some person. So if you in your home, you call some small kid, it has a name, somewhere supposedly an Ahmed, but you always call him baby, because he is the smallest child, so you always call him baby. So it is just like a different name given to some reserved word of your C language. So that's why you use this type def over there, and this type def is over here being having the syntax type def existing type over there, and then a new type name. Now, why you are going to use this? For example, let's say I will show you this with the link example, and that is something very important over there. If you see this example, you have type def, existing type, new type. Now, supposedly every time you want to declare a integer, but you write down int x, int y. Now, int, we know it's a short form for integer, but I don't want it that, okay, int maybe sometimes does not understandable. So what is int or what is float over there? So you can write down in your C language type def int space, and you can write down the whole word in integer or anything. It is just like you define the word. If you remember it in your C language, we have done this one in chapter number 6 over there in detail, that over there, just below that one, maybe even before the structure, you used to have this defined word. And after defined word, you had, let's say this was size and this was 10. So this was the word size was given. Whenever the word size is going to be used, 10 is going to be used. So it's just like exactly the same thing, but this time you're not giving a number. You are telling it that over here, let's say I want to inside the main def over there. Let's say I call it type def, and here I call it int. And whenever I'm going to use the word integer, this means that I am actually referring to int. So now if I here want to have it, let's say after this of structures and all that stuff, you can use this type def inside structure. I will show you the example as well, but I'm giving you a short example at present. So here, if I want, I can define int x equal to 0 like this, but I don't want to use the word int over there. So I can use it integer x equal to 0. This will still work. So this is just like an aliases or a synonym for the word integer over there. And now I can use it x plus plus over there, over there. This will still work. I can run this command and it will not give me an error. You can see it's working. I can print x, whatever. Similarly, you can do that type def for, let's say, float as well. So let's say I want to call it a floating number, floating underscore number over there. And here now I can call it a floating number. You can see automatically floating number y is equal to 9.0. So I can now have y plus plus or y equal to, let's say, y plus 0.2 over there. Sorry, y plus, it's going to be capital and 2 over there. Sorry. So type def is just creating an aliases of the reserved words inside your C structure. So coming back to the slides over there, you can now use this one inside your structure as well. Now what this means actually, now see this thing. Now applying this on the structure over there, type def before the struct command. Now, whenever you are going to make a type def, let's say I go back on this one, what you were doing, I had a structure made over there. The nomenclature was made. So when I'm making a structure for a student named Sn, so what I'm doing it, I'm getting a structure word. The record is the name of that nomenclature by which I want to make its structure. Sn is the name of that structure. So now by using type def, what I'm going to do, I have called type def struct. Card is the name of that nomenclature by which I want to make that super data type over there. And card is the word which I want to give it as an alias. Now, what will this do? Whenever I use the word card, my card, this means that my card is now a structure of the nomenclature card. So what this means now, let me just use it over there. Let's say after this thing, I want to use it. Type def struct record over here. And here, I call it, in fact, I have already used a student. So STD, let's say. Type def structure record STD. So what I've done now, this word struct record STD is telling me that now instead of using these three, so now what I can do, I can take this off. I can take these three off. And now I can just call it STD Arsalan. STD PF brackets 98. Same thing. I'm just doing exactly the same thing. So now it will be static student over there like this. So what has type def done? It has created a synonym or an aliases. Aliases is a just exact word for this struct record word. Previously, when I was using type def, so it was just using for the int. Now, since struct record is actually that reserved word, record is now a part of that C language over there because it's now a nomenclature for that structure which I've defined. So STD word over there, I can use it for student as well, totally up to you. So STD, so I can now define STD Aslan, I can define STD PF, standard, STD static student. So this is, if I just run it, this will still run and it will not give any problems. I hope you're getting the point. What is type def doing over there? So type def actually creates it. You can use it for the pointer. You can use it for an array. You can use it for a simple over there. Totally up to you. You can do this one for type def. So benefits of type def, it's a shorter, cleaner code. Now, if you see this code, now this is easily understand. Okay, STD Aslan, STD PF from 0 to 98 over there. In fact, 97 over there, because 98 is not going to be the number of the array. It will be from starting from 0 up till 97. Then student is a pointer to an array, and afterwards you will be sending out its address by using the AND operator. So it's better readability also, because now you know card deck is the thing. So deck is an array of 52 cards, so it's easily understandable. So type def actually makes your understanding of the, and by nomenclature, normally it's a standard, you can call it, not exactly in C language, that whenever you are defining a type def, you call it in caps lock, STD. Here, this will be STD, sorry, on this one, I have to change it, STD, STD, and this one. Why? And I have used this one caps lock over there or in caps over there. So this is a normal, this actually tells it, the whoever is going to actually proofread your code, that okay, this has been type defined by an aliases, and that's why it's in caps lock. So this is the normal capitalization is being done always to distinguish it from the variables, because you can have an integer variable as well, but here I have defined type def over there. For int, it is integer, integer, so that's why it is in caps lock. So it actually, okay. So if you are now going to combine type def with structure definition, so this is something very easily over there. You define a structure before your main command over there, main function over there, and then afterward type def struct card. So now you can just use the word card, and then you can do it easily. Plus, this is a separate type define. You can do this one inside over here as well. Here, this will be type defined before struct card. Previously, it was just simple struct card. Now this is type defined struct card. So at the end, this is the card. So now you only have to use the word card over there. So I have defined over here, I have defined the structure here outside the main function, which is of course already there. But if I want to now have this type define, I can write this type define over here, type define struct record, and here before the semicolon, I can write down std caps lock, and this will still work. So there are two ways of defining for structure, a type define over there, that is type def over there. So you can use any of these two very easily over there. And this type def really makes your code readable. These two are not just written for the benefits over there, they are really beneficial, because whenever you are going to write down a code, let's see over there, whenever you write down, this means a little understanding. STD is student name, a short form for it. You can use a student over there, but I have not used a student over there because student was already a pointer. That's why I've not used. Otherwise, you can use a student Aslan, student PF, array over there, whatever stuff over there. So you can use it easily. So type def is actually something like this. So you can combine this type def structure and make your life easy for understanding over there. And remember, next thing, type def is over there. So different systems may have different type, size of type. Now, this is a little problem over there, that if you have type define integer, that is on system A, type define long integer is on system B. So this is different for different. So your code needs integer everywhere. So here integer count is equal to this, integer array is equal to this. So just change the type def to port to another system. So if my code is working on maybe supposedly Mac OS, and supposedly I take it to an Intel system, of course I'm using the same compiler, so it will not be a problem. But supposedly if I take it to an AMD system or something like that, and there the system is different over there, or maybe I'm going from a 64-bit operating system to a 32-bit operating system, then this problem of integer having different byte. That's why, if you remember it at the start of the course, I told you that you have to have the same compiler. That's why I asked you, everyone has the same C language compiler, GCC compiler over there. Whoever asked me at that time that we can use that AMSys or something like that, I told you don't use that. Maybe there are some discrepancies or some differences over there. That will be a problem, because when you take a code from me and then run it, that will be a problem for you. So type def, you just need to change on the start of your code if you are changing from one system to another system, because int is of different size, or long is of different size, or something like that. Remember, type def does not create new types, just new names for the existing type. Remember, this is just an aliases or a synonym for your reserved word or whatever structure you are passing over there. Then some question about type def. Write a type def statement that creates a shorter type name dice for structure type struct dice. I guess very simple. You have to have type def struct dice and then capital DICE over there. I guess I have write it right. Yes, this is the answer. Type def struct dice over there. And remember, this is case sensitive over there. So this dice and this dice, they have the same spelling, but here D capital is over there. So this is D capital over there. So this is something very, very important over there. Next question over there, create a new name with type def creates a new type. Creating a new name with type def creates, no, this does not create a new type. It is just an aliases or a synonym, as I have already told you. So this is false. Type def does not create a new type. It simply creates a new type name as an alias for an existing type over there. I hope you are understanding with this type def thing. One thing very important, this case study overview, I'm not very good with cards over there, so I'm not going to go with this example, but strongly advise you to go through this example, those who are familiar with cards and playing cards, because there are 52 cards in your game whenever you have 4 people are playing over there. Kindly go through this case study overview and the card structure definition over there. The example is also available inside your over here. I guess this is available for the card structure. I guess this is the same example. I've already done it. Yes, this one example. So it's a very, very long example, but still try to run this thing. I will just show you the answer of this thing. You can see you are printing everything. All the 52 cards are being displayed over there. You can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yes, 13 into 4, 52 cards are being displayed. 7 of hearts, deuce of diamond, 10 of hearts, and all that are being displayed over there. Kindly go through this one, because here the structure is the same, face and suit over there, and type defined structure, card, everything is the same. So please kindly go through this example. You will understand how structure, how type def, and how all are being printed over there with these 3 functions, which are taking every time a pointer or maybe a value, pass by reference or pass by value over there. So this is the main function, just like the same example. Kindly go through this one. Those who are familiar with the cards, I'm not very good with cards, never played in fact in my life. So I have no idea how this cards and diamonds and all that fun are actually done. So you will be having, and in fact, when you have made this thing and you understand this thing, then you can make a code to play with that cards over there, and you can have that function made so that you can play a card game over there. So you can shuffle as well. So kindly go through this example over there or this one. So I will, this is a sample output, the same output over there. So you kindly have to go through this one yourself over there. And if you want to shuffle it, you can use the rand function. As you can see over there, the rand function, the random function. So you can use it algorithm over there. You can have another algorithm, which is called as the Fisher-Yates algorithm, which is over here in this form. So this will also work over there. So you can implement it. This is a very good example to understand structures and card. Implement this Fisher-Yates algorithm and you will have an understanding over there. I will not go through this card shuffling because it's actually from the code over there. So I will just go on to the next command, which is union. Now, what is union over there? The last part of this today's lecture. A union is like a structure, but all members share the same memory location. Now, this is something very, very conceptual. Understand this thing. It's a structure combining two values of the over there. It's like a structure, but only one member can hold a value at any given time. Now you will understand with the example a little bit what I'm talking about over there. So key differences from structure, each member gets its own memory. So if you have a structure, you have a grade over there, you have an int over the grade over there, you have car grade, you have quiz 1 marks, you have quiz 2 marks, you have quiz 3 marks. So you are having each member having a memory. But in union, all members share the same memory. Now, how that is done, see this thing very well. When you need to store different types at different times, but never simultaneously, then you use union. And how? This one, if you have a structure, your structure has two members. One is int x, one is double y. So they both will be taking some, and that will be 12 bytes. But when you are talking about union, you have int x or double y, it will be only taking 8 bytes. Why 8 bytes? Because double y takes 8 bytes, int x takes 4 bytes. So double y is the highest size. So that's why union is going to take 8 bytes. So anytime you're only going to store y, which is because double, that will be taking 8 bytes. If you'll be having int x stored over there, then it will be also taking 8 bytes because the maximum size available in your union is 8 bytes. That is for the double. So union uses the size of the largest member only. But here you are saving the space. Why? Let's just see in the next slide. I will tell you how you are going to declare a union. Union number int x double y. Union declaration over here, but simply just like structure, you had it here. This is union number int x double y. What this means? It creates a type called union number. It can store either an int or a double. So either you can store this or either you can store this. Totally up to you. Both uses the same memory location. Size is equal to the size of the largest member, as I told you, because here int is going to have 4 bytes, double is going to have 8 bytes. So it is going to have 8 bytes for the double. You must track which member currently contains valid data. Now, this is your code, which is actually going to take into consideration that what is being stored inside over there. Now, how you're going to use unions. Now, see this thing very carefully. Before the main function, you have defined the union. Same way, just like structures, nothing fancy over there. Again, semicolon, semicolons, and after the main parenthesis, also a semicolon. And inside, you are now defining a union number value. So again, just like structure, same thing. You're having a union number. So value is the name of that union which we have created. Value dot x is equal to 100. So what you have done, you have taken x inside and you have named it at 100. Now y is not going to be stored over there. So printf value dot x. So you are having this stored over there. And then afterwards, then you change value dot y is equal to this thing. So this will still print over there. But now this time when you are going to have printf value dot x, wrong, because x no is no longer valid. So any given time only one is going to be active. Now you may be arguing that why we are going to use this. What's the advantage of this thing? Sometimes in code, you have to store that that student was there or not. So maybe you have two character variables inside it, and one is going to store something present, other one is going to store absent, P or A. So in this way, you can have a different over there. So union actually is creating a structure where only one of the member is going to be having a data, other one is not going to have a data. So your code needs to track it that it is having the data in which variable over there. So accessing the wrong members gives unpredictable results because that memory is not available. So it is only available for either X or either Y. In this case over there, using unions over there. So operations on union, very importantly, assign one union to another of the same type. What you can do, you can take the address of a union, of course, with the AND operator, very simply access the union members again by the dot operator and the arrow operator. Please remember, this is the arrow operator because these slides are converted. That's why they have made it into an inverted question mark over there. Zero initialize, which means union number val is equal to empty. So this will be a zero initialized over there. What you cannot do, you cannot compare union just like structures. You can't compare, you can compare the structure members, you can compare union members, but you can't compare the whole union with another union. So assign unions of different types over there. So you cannot assign union of different types as the same restrictions as structures over there. So these are the operations on unions. And whenever you are defining or initializing a union, you can have union number vol1. Vol1 is the name of that union that is having 10. So this initializes X because X is the number one. But then you have value 2, this is 3.14. This will be warning, it truncates to int because there is no one inside. Int is X over there. So this 3.14 will go on to the first member, but since it's integer, so 0.14 will be gone, 3 will be assigned to the first number over there. So that will be 3. So trying to initialize the type of the second number, that's wrong. If you want to define it, then you have to give it 0, 3.14, then it will be defined over there. So union is something like this. Then next an example, let's just see over there. Again, simple X and Y union over there. And then afterwards, you have int main over there, union number value. Here you are defining value.x equal to 100. And now value.y will contain garbage because it's not defined. Only one is going to have a value over there. Then afterwards, you define value.y. This time X will be giving a garbage value. So I hope this is example. Let me just go on the website as well. Type define, not type define actually. I'm going to talk about the unions over there. So when you're talking about the unions over there, let me just open it. Kindly go through these links. These are much better links as compared to your book. You can do the book reading as well, but book reading afterwards when you've gone through these links, because in these links, the data presented is much easier over there. So a union is similar to a structure that it can store members of different data types over there. So same thing, same definitions. We just gone through the slides over there. Now here you have over here a union, my union. Now here, to create a union, uses a union keyword and then create a variable from it, just like this structure over there. So here you have union, my union, u1, and create a union variable with the name u1. Now, if you want to access the union members, when you have done it, union u1 dot my number is equal to 1000. So now, since this is the last value written to the union, my num no longer holds 1000. Its value is now invalid. So now when you are going to access my letter is going to be there. My num is going to be not printed because only one of the value is there. Remember, union can have 3 or 4 different characters. So maybe if a student is being awarded, let's say I'm making a code and that has to award like something, either an F grade or different grade. So inside the whole thing, I have 5 or 6 different grades. One is A plus, one is A minus, then there is A, then there is B plus, then is B over there. So I have in the union, like all of these grades, only one of them is going to have a value. That is going to be that student grade. So otherwise, everything will be garbage. So unions are there when you want to assign one member a value, the rest of them are empty. So you can assign this thing by using this one. So this thing is going to print garbage. This thing is going to print A, because the last thing which you have assigned is over there. So if your code knows that what is going to be printed, that will be printed over there. Plus, if it is going to be garbage over there, you can check that using your if else statement, that if it is garbage, it's not going to print. So I assign for all your students, 98 students over there, I assign a union over there, and I assign each one a grade respective to whatever you have got over there, and then use a for loop to print for each student what grade is going to be printed, and then if else statements to check that which has to be printed, which member of the union has to be printed or which member has to be not. So that can be done, because of course there will be some realistic value, otherwise the garbage value will be there inside the members of your union which are over there. So I hope size of the union, again, you can use that function operator, just like your arrays, integer, or something like that. So this is going to be only printing here. In this case, this is 4 bytes. This is character into 36. So what is going to be happening over there? I guess the answer is very simple. Here, this will be my strings 36 over there. So if largest number is 36 bytes, the entire union will be of 36 bytes. Otherwise, if it was a structure, then 36 plus 4 bytes for the integer, it will be 40 bytes. So only one is acceptable, only one value is stored over there. So the largest size of any member defines the size of that union over there. When to use union? Very, very simple answer. Use union when you need to store different types in the same location. You only use one type at a time. Just like I give you an example that if you have like 5 or 6 different grades of your students and only one grade is going to be assigned or given a value over there. Saving memory is very important. Remember, you are still at present creating very, very small programs or maybe like 100 or 200 lines. So unions are only used whenever you are going to save memory. Then that is actually because structure creates those structures over there, and that becomes very difficult for you to understand how that is going to be done. Then let's go through some self questions. I guess, and these slides are going to open. How is the union different from a structure? Of course, it's different because the memory allocation is only for the highest the member over there. A union shares memory location. All members, only one member may be stored at a time. You must track which member is currently stored. Struct gives each member a separate memory, as I have told you. Then another question, for a union with 4 bytes int and 8 byte double, the compiler must reserve 12 bytes. Wrong. It will always be 8 byte only because it's a double. The last size will be 8 bytes. So only 8 bytes will be needed. The size of the largest member over there. The word is union over there. Then I guess coming on to the bits over there, I will discuss this one in the third part over there. So I hope you have now got what I'm trying to tell you over there for the structure, how passing a structure through a pointer, pass by reference, and all that. In the third part, I'm going to discuss about the introduction to bits, the bitwise operator, and this classical symbol of how you are going to left shift, right shift the bits over there. And this is called as bit manipulation whenever you are doing it over there, or masking some bits over there, because you have to do the AND operation, the bitwise AND over there, or the bitwise OR. Remember, this is different from the AND operator which we have used over there. That was two types, AND symbol or the OR symbol, the straight vertical line over there. And this was a bitwise XOR. This was triply different from that one. So this is a bitwise complement over there using the symbol over there, and the left shift and the right shift over there. So these are all the bitwise operators over there. This is the AND operator. This is the OR operator. Remember, this is different from the 2 times AND when you write it, because there you are doing a logical AND or a logical OR, that this is equal to this or this is equal to this, then that is different. Here you are doing bitwise. Each bit, if integer is being AND with another integer, so all the 4 bytes, which means all 32 bits are being AND with the other 32 bits over there. So we'll go through this one in the third part, a very small part over there, and I will complete it. This is going to be a second part of this slides as well. So I hope you have got what I've tried to do this one today. The structures I've again displayed or again discussed it over there using the pointers, how you're going to pass the structures as a reference, as a value. And we have also talked about how you are going to pass it using a function over there. And this is something. Let me go through this cards example over there. And I guess this will be much, much easier for you, and you can do the lab after this part. Thank you, and Allah Hafiz.